Oh, y'all, so 9.3 deals with exponential functions. And y'all remember exponential functions come in this form. All right, let one in real quick. So exponential functions will have a base. That'll be some number. And then the variable is actually the exponent on those. Yeah, so this could be like 2 to the x, 3 to the x. But y'all, now the variable's an exponent instead of down here where the base is, okay? Add that one in real quick. So we'll be looking at graphs of these in a second. But first, they wanted y'all to learn about a new constant we got in math. So y'all are all familiar with pi 3.14. So we got a new constant that we deal with when we're messing with exponential functions and stuff. And it's E, and this is called Euler's number. And it's a constant they found when they was doing interest problems and stuff. So I'm not going to get into all that. We're just going to learn how to find it. So I'm going to show you how to find that on your calculator, okay? So let me share. So there's two places you can get the E. The first one above the division over here, you see a blue E. So if you hit the second button and divide, it'll pull the E on the screen, and then you can hit enter. And they usually want us to approximate this 4 decimal places. So this would be 2.718. So the fourth decimal place is a 2, but since it's got an 8 after it, we're going to round that 2 up to a 3. All right, y'all, that's one place you can find it. Now, the second place, if you look over here to the left side of the 4, there's an LN button. Right above the LN button, you got a blue E to the X. So if you'll hit second LN, it'll pull the E up and you can actually put in the exponents on it if you want to, instead of having to go and use the little upside down caret. Um, so I'll just put it to the first power since we're just finding E. But y'all, that's the two places you can find E on your calculator, okay? So let me show you what they want us to do on the first two problems. On these first two problems, they want you to use a calculator to approximate the exponential expression to 4 decimal places. So y'all, you have no choice. You got to use some kind of calculator on this because these are not able to be done by hand, okay? So for the first one, they wanted me to approximate e to the 6. And when you see these little curvy equal signs, that means you're approximating the answer, okay? We're rounding it off. So y'all, we would go to our calculator for that. And it was e to the 6. So when I got exponents, I always use the second ln to bring up that e. And then I'll put in my 6 for my exponent. And y'all hit enter. So we got 403.428. The fourth decimal place is a 7, but y'all, that's got a 9 behind it, so we're going to round that 7 up into an 8. So that would be 403.4288. So in this section, they're really big on rounding stuff off to 4 decimal places, okay? All right, so they wanted you to play with one with a negative exponent. So e to the negative 3.48. And y'all, when you got negative exponents, your answers are going to be really, really small numbers, okay? So let's go share that one and go to the calculator. I'm going to clear all that off. So I'm going to hit second LN to get the E with the exponent and then put in a negative 3.48. Hey, y'all, let's hit enter. So that'll be 0.030. So the 8's in the fourth spot. It's got a 0 after it, so we'll leave that at 8. So remember, if the number after your digit is 5 or higher, I'm going to round up. If it's 4 or less, I'll leave it the same. So y'all, that's just what they wanted you to do with these first two problems is just sort of play with it and get familiar with that calculator and able to find the E on there, okay? So now let's look at graphing exponential functions. So once again, we're looking at stuff like this. Okay. Um, so there's the thing about these exponential functions. The graph of the basic exponential function, it's going to pass us through the point 0, 1. No, that's because no matter what number you have here, if that exponent is a 0, that answer will be 1. So I'm going to go prove that to you. So say my base was 5, and I raised 5 to the 0 power. Anything to the 0 power, y'all, equals 1. That can be 9 to the 0 power. It equals 1. So y'all remember, anything to the 0 power equals 1. So that's why these graphs cross through the point 0, 1 for the basic graphs, okay? All right, these graphs are continuous graphs. So continuous, I mean there's no asymptotes or no holes in the graph. They just keep a smooth curve. So they're continuous. And then the last thing that's really common with them, one end has a horizontal asymptote with the x-axis. So one end of it's going to be really trying to get close to that x-axis there, okay? So it depends on the base to determine which end is going to have that asymptote. So y'all, let me just play with a couple examples here, sort of show you what's going on. So for this one, I'm going to graph y equals 2 to the x. All right, so I'm going to see some numbers first before I make my scale here, okay? So like I said a while ago, if x is 0, 2 to the 0 equals 1. So remember, we said they all cross through the point 0, 1 up here. If x is 1, 2 to the first is 2. If x is 2, that'd be 2 squared. So that's 2 times 2, which is 4. And y'all, let me do another one. How about if x is 3? That'll be 2 to the third power. So 2 times 2 times 2 would be 8. So I'm going to go out about 10. Okay, so 0, 1 is crossing right here at the y-axis at 1. 1, 2 would be right 1 up 2. 2, 4 would be right 2 up 4. And then 3, 8 would be right 3 up 8. So these graphs sort of make a nice uphill curve. Now on this left side, I'm just going to do a couple negative ones so you can see how this one's trying to get closer to the x-axis. All right, y'all, so 2 to the negative 1 power. If you want to use that calculator, you can do 2 exponent negative 1. That'll give me 0.5. And if I want that as a fraction, I can hit math, enter, and that'd be 1/2. So when x was negative 1, I got a 1/2, and I had a negative 2 there. So let me do 2 exponent negative 2. I get a 0.25, but if I turn that into a fraction, I get a 1/4. So this left side at negative 1 was at 1/2, so that's about halfway in there. At negative 2, it was at 1/4. So see, this side is trying to get closer. So negative 3 would give me a 1/8, a 1/16, a 1/32. This left side is really getting close to your x-axis here. So this little graph sort of comes up, crosses over at 0, 1, and then starts shooting up towards infinity. So at 4, 2 to the 4th would have been 16. If it was 5, 2 to the 5th would be 32. So this thing really, really starts doubling quick, okay? So if your base is a number greater than 1 like this, then it's going to have that shape right there. If that was a 3, it would have the same shape. It's just that it would grow a lot quicker. So the bigger the base, then the quicker the graphs grow, okay? So y'all, that's what happens when your base is a number greater than 1. So let's look at one. So let's graph one that looks like y equals 1/2 to the x. Whoops, let me move back up. So this is a fraction, so watch the shape of the fractions when we graph them. So I'm going to make me a table. Now, if I put a 0 there, 1/2 to the 0 is still going to equal 1. Now, if you was to do that one on the calculator and you wanted to figure out what that equaled, you would have to put that fraction in parentheses. And then put your 1/2. Arrow right. Whoops. Arrow right, close parentheses, and then raise that to the 0 power. So if you got fractions, the exponents, they got to be in parentheses, okay? But y'all look, when I hit enter, I still get 1 on that, okay? All right, if I put a 1 there, 1/2 to the first power is 1/2. If I put a 2 there, 1/2 squared, you square the top and the bottom. So 1 times 1 would be 1. 2 times 2 is 4. So I get 1/4. So as these numbers get larger, heading towards positive infinity, these values are getting smaller and smaller. So y'all let me do some negative exponents on this and see what happens on that side. So let's do 1/2 to the negative first. All right, so let me clear everything out. So parentheses, alpha y equals enter for my fraction. I got 1/2. I'm going to arrow out, close parentheses. And then my exponent is a -1. So when I hit enter, I get 2. Now let me do my -2 also. So parentheses, alpha y equals enter. I got 1/2. Arrow out of that, close parentheses. And then this exponent will be the -2. So that gives me 4. So when it's a fraction, that left side is sort of growing up, and the right side is trying to get to the 0 on the x-axis. So y'all, let's graph that real quick. All right, so I had 0, 1. So we said they all cross through there on the basic graphs. 1 and 1/2. So that's about halfway up between 0 and 1. At 2, I was at 1/4. So that's even closer to the x-axis. So this right side is the side that's going to form the asymptote. So at -1, we were at 2. So -1, there's 2. At -2, I was at 4. -3 would put me at 8, and so on. But y'all, this one would come in, go downhill, cross over the y-axis at 1, and then as it heads towards infinity, it's just trying to get closer and closer to the x-axis. So the fractions go downhill left to right. The numbers that are bigger than 1, they went uphill left to right. So if that was a 1/3, 1/4, same thing. It had the same shape. It would just either be steeper or flatter, okay? Now, y'all, one where they try to get tricky is when they do this one. Fx equals 2/3 e to the x. So on these, they're just going to have you pick one of their four pictures. So really, since e is just an approximation, you really have no choice but to do that one on your calculator, okay? So I'm going to go to y equals, I'm going to put in my fraction, alpha y equals enter. So I had 2/3, 2 on top, 3. Then I'm going to arrow right. I'm going to hit second ln to get e with the exponent. And I'm going to put me a x there. So this one, if you want to look at the table, second graph, see there's really no way to get these kind of values by hand, okay? So now this one at 0 has 2/3, but remember that was 2/3 times e to the x. E to the x would be 1, but when you multiply by the 2/3 in front, that's why they're getting a 2/3 there, okay? But y'all remember, e is bigger than 1, so this graph is going to go uphill, left to right when I hit enter. And there you go. See how it's sort of going uphill, left to right. So y'all, that's the trick on those. When you're trying to graph them, they all have basically the same shapes. Like I said, if the base was bigger than 1, and then if the base is a fraction, they're going to sort of go downhill. Look, my share went down. Alrighty. Alrighty, y'all. So, y'all remember back in 7.2, we did transformations where we moved graphs up and down, left and right, and we flipped them over to x-axis. So we're going to do transformations in this section. Okay, so we're going to have three transformations we look at. The first one is the vertical. And y'all, we've done vertical before. So a vertical transformation would be y equals a to the x plus or minus b. So you're adding a number at the end of the function or you're subtracting a number from the end of the function. Now, it's going to do the same thing it did back in 7.2. If b is positive, then the graph is going to go up. If this b is negative, then the graph is going to go down. Same exact thing as in 7.2, okay? We had a horizontal shift. That'd be like this. Y equals a to the x plus or minus c. Notice the difference. On this one, you're going to evaluate the function first, then you're adding the b or subtracting b. On this one, you're attacking the x before you evaluate the function. Just like when the x was in parentheses in 7.2. if C is positive, now this is just like in 7-2. When you added to the x, you went left. So sort of backwards if you think about it. And then if C is negative, so you're subtracting from the x, it goes right. So that horizontal is always backwards from what you think, okay? But this, you're attacking the x before you evaluate it. Here, you're evaluating it with the x, then you're adding the number, okay? Now we got one more move, and that is reflection over the y-axis. Now in 7-3, we put a negative in front and reflected it over the x-axis. Well, here, instead of putting the negative in front, you make the exponent negative. By making the exponent negative, it reflects it over the y-axis. So if it was going uphill, it's going to reflect it and it'll sort of go downhill, okay? Now, y'all, one thing you got to realize, we'll look at some of these in Math Lab. In Math Lab, the biggest thing that kills people in Math Lab, you must put your base in. You got to put your base. By default, they're going to have an E there for the base. So you got to put what your base is. So y'all let me go and sort of explain what I'm talking about on here. So let me try to get that pulled up. All right, I'm going to share my screen. See on this one, they got f of x equals 2 to the x plus 5. So they're attacking that x with that plus 5. So y'all let me pull up my chat. So what do y'all think that plus 5 is going to do? So on this one, since I'm attacking the x, it's going to go left or right. Since that is a positive 5, we're going to go left. So y'all, we would come down here to C, the one that says go left. Our base would be the 2. So y'all, you got to put the base on this part. When you check the answer, it's going to want us to graph it. So we click the enlarge the graph. On the second row up here where the tools are, the first one's logarithms. We'll learn about them later. The second one is your exponential tool. So click the exponential tool. Click anywhere on the graph. It always starts it at the same place. Now, do y'all see the little gray box they pulled up? On the bottom left, it says base. By default, they got an E there. We need to backspace that and put a 2. Whatever the base of your problem is, you got to put it in here, okay? And then that plus 5, I said move me left. So I'm going to go to horizontal and move that left to -5. And then save it. But y'all, You got to change the base because e to the x plus 5 will look just like 2 to the x plus 5, okay? There's not big enough differences to sort of tell the difference. So you got to change that base. All right, then you check your answer. You go to your next question. This one has 6 to the x minus 5. So this one they want me to graph first. So grab your exponential tool, click it anywhere on the graph. The bottom left, they got a base of e. I'm going to backspace and make that a base of 6. Now this one, they're subtracting 5 after the function. So since they're subtracting 5 after the function, it's going to go up or down. So since that's a negative 5, it's going to go down 5. So that'll be vertical. Move that to negative 5. And my graph went down. Save that. You're going to check that answer. And then it's telling you, okay, this is a basic exponential function. 6 to the x. And then shifted down 5 units. So some will have you put the moves in first, then graph it. Some of them will have you graph it, then put the moves in. So this one's got 2 moves. So really, they're not doing any moves with reflection over the y-axis. All of ours either were up and down or left and right on this one, okay? Um, so start with the graph of y equals 2 to the x, that's your base. Shift it blank, 5 units. So up, right, left, or down. Since they're adding 5 to the x, it's going to go left when you add. And since that 4 at the end is being subtracted, that's going to go down 4. So on that one, you check your answer and then graph it. So I'm going to click the enlarge graph. Grab my exponential tool, click on the graph. Go down in the bottom, change my base to a 2. So let's see, I had 2 moves. So the plus 5 went left horizontal. So I moved it left. And then the minus 4 went down 4 on the vertical. All right, so it went left and right. Save that. Check your answer. So y'all, you just got a few doing that, okay? So at the end of 9.3, we actually have a couple word problems dealing with an exponential type equation. So y'all, the equation we're about to learn is A of t equals p times 1 plus r over n, all raised to the n times t. So t is your variable, so that's why t is the exponent on this one. All right, y'all, so this equation shows you the amount of money available in the account. So this would be the amount in account after T years. Okay? So this is like investments. You invest 5,000 at a certain percent interest rate and all this. This will show the amount of money in the account at any time T. P. P is your principal balance or your starting amount. So you invest 5,000, 5,000 will be your starting amount, okay? Then it's 1 plus R divided by N. R is the rate or the interest rate. Now, when you put that interest rate into the formula, it has to be in decimal form. So if they give it to you in percent form, you got to change that percent into a decimal by moving the decimal left 2 units, okay? N. You see N here, and N is up here as an exponent. N is the number of compounds per year. That's how many times they apply the interest to your money. Okay. So on number of compounds, they might give you um, annually. Annually is 1 time a year. Semi-annually. If they say it's semi-annually, that's going to be 2 times a year. Yeah, let's see. What else do they do? Quarterly? Quarterly would be 4 times a year. They might do monthly. If they do monthly, that would be 12 times a year. And so on. They could do daily. Okay. Um, but all these are the types of compounds. Annually, they would apply it once a year. Semi-annually, twice a year. Quarterly, 4 times a year, and so on. Okay. So that's what the N is. And then T up here, T is the time in years. Okay. So y'all, we're just going to be playing with this formula. And they got a couple of problems where we're playing with it, okay? So y'all, let's play with this one. Suppose $67,000 is invested at 4.5% interest, compounded quarterly. Okay, so 67,000 is invested at 4.5% interest, compounded quarterly. So for A on this, they want us to find the function for the amount to which the investment grows after T years. So basically, they want me to fill this out to come up with a formula that I can use to find my amounts after a certain amount of years, okay? So it's going to be A of T equals P. So that's my starting amount, we said. My principal balance that I started with was 67,000. Then I got parentheses 1 plus R divided by N. So let's see. R is my interest rate. That's 4.5%. So y'all, the first thing I'm going to do is change this 4.5% into a 4.5%. So I'm just turning the fraction back into a decimal. Now, to convert from percent to decimal, you got to move the decimal left 2 units. So I got 4.5%. I'm going to move the decimal left once. So I'm going to have to add a 0 so that I can move it left twice. So 4.5% turns into a 0.045. Now you can take the 4.5 and divide by 100 and get the same answer. Um, but y'all, all you gotta do is move the decimal left twice, okay? So 0.045 comes up here. Compounded quarterly, that's what n is, my compounds. Well, we said quarterly was 4 times. So we're going to divide by 4. And then the exponent was n times t, which will be 4 times t. Now, y'all, the only thing MathLab makes us do for this, they want it simplified. And the only way to simplify it is to work this part inside the parentheses. So let me share my calculator. And I'm going to do what was inside those parentheses, okay? So let me quit this graphing. So that was 1 plus 0.045 divided by 4. And enter. Or you could do this 1 plus alpha y equals enter for your fraction. And you can do 0.045 over 4. Either way, y'all, okay? So it wants that in there, 1.01125. So you got to write that out as 1 point whatever, and then bring in my 4t. Y'all, this right here is what MathLab wants for that answer, okay? So let's go back to the MathLab. Whoops, I ain't doing this on MathLab, am I? All righty, so that was A. So B, let's see what they wanted for B. B, they want to know, they want to find the amount of money in the account at T equals 0, 4, 7, and 10 years. Okay, so put a 0 in for T, see what you get. Put a 4 in for T, see what you get, and so on. So T equals 0, I'll have so much. T equals 4, I'll have so much. T equals 7, and then T equals 10. Well, y'all check this out. At 0 years have passed. So if you put a 0 in for the T, 4 times 0 is 0. This whole thing here, anything to the 0 power is 1. So 67 times 1 is $67,000. So if no time has passed, you better have what you started with, which was your 67,000. But y'all, what we can do on that, I'm going to show you 2 ways to do this. The first way is to come in and punch them in individually. 67,000 parentheses 1.01125 close parentheses, and then this would be when I have 4 times t, which was 0. So when we hit enter, we get 67,000. Now my next one, t was 4. So I would do 67,000, 1.01125, close parentheses, exponent will be 4 times t, which is 4. Now this is an investment, so hopefully your money goes up. So when you hit enter, you're at $80,000, 132. And let's see. They want me to round these to the nearest dollar. So the nearest dollar would be where the 2 is right before the decimal. But y'all, that's a 9 after that 2. So we would round that 2 up into a 3 so that we get 80,133. All right. So you would do that next with a 7. 67,000 parentheses 1.01125 close parentheses. This exponent was 4 times t, which is 7. So I'm still looking for money to go up. So when I hit enter, I got 91,640. So let's see. The dollar is the 6. It's a 0 after it, so I'm going to leave that a 6. And then finally with the 10, 67,000 parentheses 1.01125. Close that. And then this one was what? 4 times t, which is 10. So after 10 years, if you invest $67,000 at a 4.5% interest, compounded quarterly, you will have 104,800. And let's see, the 3's in the dollar spot, but it's got a 2 after it, so I'm going to leave that a 3. So you have almost 105,000, okay? So y'all, that was one way to do this. The other way, I'm going to go to y equals. I'm going to clear everything out. I'm going to put in the function 67,000 parentheses 1.01125 close parentheses, and the exponent will be 4x. When you're doing the y equals and stuff, you got to use x's for your variables, okay? Now, I don't even care what the graph looks like, but y'all, the graph would really go uphill over time because your money's going up. What I want to look at is the table. So second graph for my table. So do y'all see that? At 0 years, I'm at 67,000. So the calculator is going to round it to the nearest dollars on it, okay? Now, if I click on these numbers, let me go down to here to 4. So at 4, I ended up with 80,133. But y'all, if you want a decimal form of that, if you highlight the 80,133 and look down on the bottom of that bar, y1 equals 80,132.99. That's the same decimal that I got a while ago, and I had to round it. But a y1 will round it for you. Now, if I wanted cents, the 2 decimal places, then I would click on the numbers and look at the decimals here, okay? So then we had 7 years. I had 91,646. And then at 10 years, 104, 813. But these were all the decimals that I converted to get those numbers, okay? So the calculator can be really nice at times and it'll round them off for you. Or if you click on it, it'll give you the decimals. All right, y'all. So one more problem in this section. And then we'll take our break. So on this one, on Melissa's sixth birthday, she gets a $5,000 CD. So a CD is like a certificate of deposit that earns 5% interest, compounded semi-annually. So if the CD matures on her 13th birthday, how much money will be available? So, sixth birthday, you get a $5,000 CD, earns 5% interest, compounded semi-annually. So if it matures on her 13th birthday, we want to know how much money will be available. So y'all, we're still using the same formula. All right, so first, principal balance. We started with, what they say, 5,000. Then we got 1 plus. So y'all, let me ask y'all to do this. Change this 5% into a decimal. So is anyone on there that can change that 5% into a decimal form? Good job. That'd be 0.05. So we just moved it left twice. Good job. N. What did we say N was if it was semi-annually? 2. Good job. That was 2 times. And then it'll be 2 times T. So what is T for this one? Because they gave us a starting birthday and an ending one. So Ben, you're right, right? What was that? 13 minus 6 gave us 7. So we're basically finding A of 7 years. Now, y'all, this one wants me to round it to the nearest cents. So round to the nearest cent. All right, y'all, so we would go punch this on our calculator. Since there's only one of them, I'm just going to use the calculator and not do the graphing. Because you can almost punch in one by the time you did all that graphing stuff. So we had 5,000, parentheses, 1 plus, what'd y'all say, 0.05 divided by 2, close parentheses, and then our exponent was 2 times 7 years. All right, now she started with 5,000, so it better go up. So hit enter. Looks like she's got $7,064. So the nearest cent means two decimal places. So that's the 86. But y'all, there's a 9 after that 6. So we'll make that a 87. 7,064.87. And y'all, that was just some examples of exponential type graphs, where they sort of start and then they start going up, up, up. Okay, so probably after so many more years, her amounts would go on and up and up and up. Okay. Alrighty, also that was 9 3s. So we'll do a break and then we'll knock out some of that 9 4. Okay. So y'all, I'm going to stop my share and let me pause this and share my screen. All right, so 9.4, like I said, logarithmic functions. All right, y'all, so let me describe what a logarithm is. So we write log to represent logarithm. It'll have a subscript, y, and that's going to equal x. So y'all, basically, a logarithm finds an exponent. So this is the exponent it's finding. A is the base, and y is the result. So y'all, let me give you an example to sort of explain this. So if I had a logarithm base 2 of 8. 2 is the number being raised to an exponent that equals 8. So you can look at it like this. 2 to what exponent equals 8? So y'all, what do y'all think that is? How many times do you got to multiply 2 times itself to equal 8? So let's think about it. 2 times 2 is 4, times 2 is 8. Good job. That would definitely be a 3. So if you punch this logarithm on your calculator, it would give you the answer of 3. So you're looking for exponents, okay, y'all? So they'll give you a base, they'll give you that result, and when we punch it in, we get our exponents. Now, there's special logarithms that we have. So, the common log is a log base 10. Now, on the calculator, it'll be shown as log. So if you see log by itself without a base, it's automatically a 10, okay? We got one called the natural log. The natural log would be a log base E. Now on the calculator, to represent a natural log, next to the, it's either the 4 or the 7, that LN button. LN is notation for this natural log. So if you see LN, it's automatically log base E. If you see log without a base, it's automatically a log base 10, okay? So they'll give us examples using these later, okay? So y'all, the first thing they want us to do in here is play with graphs. They want you to graph y equals log base 5 of x. So to do these, you're going to want to use that calculator. Now we'll say this. Remember, x is those results. So if I was going to graph this, and then let me do a little graph here, because all these graphs have a similar shape, just like the exponential graphs did, okay? Now this one, since I'm dealing with a 5, I'm going to go by 5s. Same thing here. All right, so the smallest x I can have on these is a 1 so far. So what exponent would I raise 5 to equal 1? We always said a while ago, anything raised to the 0 power equals 1. Okay? Remember, we're finding exponents that equal these results. So 5 to the 0 would equal 1. So these are all going to graph right through here at 1, 0. They're all going to go through 1, 0. So let's see, what if x was 5? So I'm trying to pick numbers that are multiples of these 5s here, okay? So if I got a base of 5 and the result is 5, what exponent would I raise 5 to equal 5? And that would be a 1. So this goes through 5, 1 right here. Next, I'm going to pick another multiple of 5. I'm going to do 25. What exponent would I raise 5 to equal 25? Well, y'all, that would be a 2. So way out here at 25, I'm up to about a 2. So y'all, what these are, they can never be negative. There's nothing you can do to a 5 to turn it into a negative number. So y'all, what these graphs are going to do, they're going to sort of make a vertical asymptote with the y-axis. They're going to come up, and then they're just sort of go up as you go to the right here. Okay? So the logarithmic graphs are sort of going to look like this. So y'all, let's graph that and see. All right, so let me clear everything off. Go to y equals. Now that was a log base 5. So y'all, let me show you how to get that log. You got a log on the front right here by the 7. But remember, The log without a number by it is a log base 10. Well, we had a log base 5. So to do that, you're going to hit the math button. You're going to arrow down till you find log base. So that's A on mine. So log base, hit enter. So my base was a 5, and then I had X. So any base other than a 10 or the natural log, you got to use this log base in the math feature, okay? Now, y'all, let's just hit graph and see what we get. And y'all, there it is. It's coming up, and then it slowly goes off to the right. Increasing slowly, okay? Hey, also, that's a trick on these. When you're graphing, just go to y equals and throw them in there. Use that log base feature under the math, okay? All right, then they had one graph y equals ln of x. Well, on that, we actually got an ln button. So let me share my screen. Go to y equals, clear that out. ln is right on the front next to the 4 right here. So if you hit ln, now remember, ln is a log base e actually. So let's put in our x. And y'all watch this graph. It is going to look really close to that last graph. Logarithmic graphs, whether it's a log or a ln, always have that same shape, okay? So y'all, they're going to play with you a little bit on graphing. But y'all, then they get into examples like this. Find the logarithm. So number 4, I got a log base 2 of 32. Now, you can do that by hand, multiply 2 times itself until you find how many times you did that to equal 32. But y'all remember, we got the calculator, remember? So we can go to our calculator, go to math, arrow down and get log base, hit enter. That was a log base 2, arrow right and put in 32. So now, log base 2 of 32. How many times do I got to multiply 2 times itself to equal 32? So y'all, when I hit enter, I get 5. So you got the calculator you can use for these, and it'll knock these all out really quick, okay? So that was 4. 5 was this one. Log base 5 of 25. So y'all, what's that equal to? Log base 5 of a 25. How many times are you going to multiply 5 to equal 25? Well, y'all, if I started multiplying out, good job, Olivia. 5 times 5 is 25. So we did that 2 times. How about this? Log base 10 of a 10. So y'all, what exponent would y'all raise 10 to equal 10? And good job, that'll definitely be a 1. And actually, y'all, you got a little property you could say on that. If the base matches the result, that answer will always equal 1, okay? All right, y'all continuing through. So most of these problems are going to be pretty much calculator problems. Log base 4 of 1 divided by 256. Y'all, I'll tell you this, when you got fractions here, you're going to get negative answers. Okay? So it's going to be a negative, and then you got to figure out how many times you got to multiply 4 to get a 256. Well, y'all, we got our calculator for that, remember? So go to math, arrow down to log base, enter. My base was a 4. My result, I'm going to make that look like a fraction, alpha y equals enter, was 1 over 256. All right, y'all, so let's hit enter, and we get a negative 4. So y'all, anything to a negative exponent is going to look like a fraction like this, okay? So are y'all familiar with negative exponents and why they end up as a fraction? And y'all, let me show you a little property of that. Any number to a negative exponent, we don't like negative exponents, so to make an exponent positive, we put everything under 1 and change the exponent to a positive. Okay, so if that was negative 4, that would be like 1 over a to the 4th, and so on. So that's how they're getting these fractions with these negative exponents. All right, y'all continuing on. What is the ln of e equal? Now remember, ln is really a log base e, so this is a log base e of e. So y'all, what's that equal? Good job, that equals 1. So let's go back up here to this property. If the base matches the result, it equals 1 for that exponent. All right, y'all, log of 1 over 10. So remember, this log don't have a base, so technically this base is a 10 here. But y'all can punch that one right on the front of your calculator. So one of y'all punch that in and tell me what is a log of 1 over 10. And you, good job, that is a negative 1. All right, y'all, log base 5 of 5 to the 4th. Well, y'all, we can even punch that in. So let's go to our calculator. So I'm going to go to math, go down to log base. That was a base 5. And then the result was 5 exponent 4. All right, y'all, watch this. Now, anytime the base matches the base of the result raised to an exponent, watch this, y'all, you get the exponent. Okay? And y'all, that makes sense. What exponent would I raise 5 to make it look like 5 to the 4th? That would be the 4. So there's a little property about that. Log base a of a to the b always equals the exponent, okay? All right, y'all, continuing on. Log base 2 of the 6th root of a 2. So, y'all, on this one, if you wanted um, to convert from a radical into an exponent, you bring out the base, which is the a. Now, since the a don't have an exponent by it, it would technically be a 1. So this would be a to the 1 over whatever the index is, which is n. So if you wanted to do, say, the square root of a number, you could write it as that number to the 1/2 and get the same answer. So this is how you convert from a radical into a fractional exponent. So for this problem, if I wanted to, there's my base 2. Remember, it has an exponent of 1 by it, so this would be like a 1 over the index, which is 6. So look here, you got a base of 2. The result has a base of 2 raised to an exponent. So we know this answer should be 1/6. Now, y'all, this one's a little trickier on the calculator, so let me show you how you would do that if you wanted to leave it like a radical, okay? So I'm going to show you something. You see on the math, you see number 5 has an x in front of the radical. That's the one I'm going to use um, to put in my radical on that, okay? So first, I'm going to go down and get the log base, enter. I had a base of 2. And then this was a 6th root of 2. So when you want to use the x with the radical, you first got to put in the index, which is the 6. And then you go math, go down to number 5 with the x and hit enter. And see, it makes that 6 look like the index of the radical. And then you put in your 2. So to use the x radical, you got to put in the index of the radical first, then hit that, then put in your 2 underneath. Now I'm going to hit enter. Now I don't want a decimal, so I'm going to hit math and turn that into a fraction by hitting enter twice. And there's that 1/6. And that really goes back to that property. If the base matches the base raised to an exponent, it always equals the exponent, okay? All righty. Um, this one will be like number 12. Let me turn this over. So number 12 is a log of 10 to the negative 7th. All right, y'all, so what's that answer? Remember, that's a log. It don't have a base. It automatically is what? And then this answer is like a log base 10 of 10 to the negative 7. Good job. That was going to equal negative 7. And y'all, you can push that one right on the front of your calculator. Anytime you don't have a base, y'all just use the log right here and then put in 10 exponent negative 7, enter. You'll get that negative 7, okay? All right, so let me try this one. Log of 256 of 4. So y'all look at this one. Anytime the result is smaller than the base, you're going to get a fractional exponent. Because when the result is smaller, it's like you're taking square roots, cube roots, fourth roots, fifth roots, and so forth, okay? So when the result is smaller than the base, you got to get me a fractional exponent. And y'all, I would go to log base for that one. So math, go down to log base, enter. My base was 256. My result was a 4. Now watch, you're going to get a decimal, but we want to turn that decimal back into a fraction by hitting math and enter twice, and we get a 1/4. So that's like taking square roots. So that means the fourth root of 256 equals 4. Okay? All right, what about this one? Log base 11 of a 1. What exponent would y'all raise 11 to equal 1? What do y'all think? Good job. That'd definitely be a 0. Y'all, that means there's another property. Log base A of 1. I don't care what the base is. If that result is a 1, that exponent has to be a 0, okay? All right, y'all try this. ln of e to the negative third. So y'all, that should be pretty quick. You got an ln, which is a log base e. So that's a log base e of e to the negative third. So you can punch that on your calculator. But y'all remember we got a property about that. And good job, that one equals -3. Okay, y'all, so on the calculator, ln is actually on the very front. So ln, and remember, I'm going to use the e with the exponent. So that's second ln, and then put in my -3. And enter, and we get that -3, okay? How about the ln of the square root of e? So y'all, you can punch that one in on the front. But remember that square root. Oh, let me go back real quick. So if you was wanting to turn the square root into a exponent, you would have e. Remember, the e's got a 1 as the top number for the exponent, so that'll be 1 over. Anytime you have a radical and there's not a number in the notch up here, it's automatically a square root, which is a 2. So this is really ln of e to the 1/2. So on my calculator, like I said, I could do ln square root, that'd be second x squared, and then put my e. So if I want the e by itself, I'm going to do second divide. So y'all, that looks like an ln of square root of e. Now remember, I'm going to get a 0.5, but I want to turn that into a fraction by hitting math and enter twice. So you get that 1/2. Hey, so that's just a little thing about converting these radicals over, okay? All right, y'all, so let me show you something that's coming up next. So we're going to be solving equations on Friday. So to solve equations, we got to sometimes convert from logarithmic to exponential or from exponential to logarithmic. So here's how we do that. Log base a of y equals x. And then I'm going to use a double-sided arrow. This means this can go either way. I can convert from this to exponential, or I can convert from exponential to logarithmic. So this equals a to the x. Remember, x is the exponent, and that equals y. So to convert from logarithmic to exponential, so this is logarithmic, and this side is exponential. I use this conversion. A is my base, x is my exponent, y is my result. Okay, y'all, so starting at 17, on these next few examples, they want to convert to logarithmic equation. So they're giving me exponential, I'm going to convert it, okay? So 17, they're giving me 10 to the fifth equals 100,000. So y'all, if we're going to convert it to logarithmic, first thing we want to do is write log. So the base of the log, look up here, the base of the log is same as the base for the exponential. Well, the base of the exponential is 10. So my little base is going to be a 10. The result of the logarithmic is the same as the result of the exponential. So that means the 100,000 is my result here. So remember, the logarithm finds the exponent. For y'all, the exponent is x, which matches x here. So the exponent was 5. So the log base 10 of 100,000 equals 5. That is the conversion from exponential to logarithmic. So y'all are not bad. Just follow where everything goes on these conversions, okay? So this next one, they got 1296 to the 1/4 equals 6. So I'm going to write log. Remember, the base of the log is the same thing as the base of the exponential. So that's going to be 1296. The result of the log is the same as the result of the exponential. So that'll be 6. And then remember, the logarithm is going to equal the exponent of 1/4. All right, y'all. E to the -4 equals K. Now, y'all, you got to watch it on these. If they got little k, you use a little k. If they use a capital K, you got to use a capital K. It's very picky about uppercase and lowercase letters, okay? All right, so I'm going to write log. The base of the log is same as the base of the exponential, so that's the E. The result is the same as the result exponential, that's the K. And that's going to equal the exponent of a -4. Now, y'all, I'll tell you the truth on this one. This one, since the log base E, we can rewrite the log base E as a ln of K equals -4. I believe it'll take it either way, but if you wanted to go on and simplify it, you can do the ln on that, okay? All right, y'all, then we got 20. P to the W equals 121. So they're just starting to throw letters at you to sort of see what you do to these. So the first thing you're going to do, write log. The base of the log is the same as the base for the exponential, so that'll be a p. The result is the same as the result of the exponential, 121, and that's going to equal the exponent of a w. So you had 4 going from log exponential to logarithmic. And then let's see, they're going to give us 4 going the other way. We're going to go from logarithmic and convert them to exponential now, okay? So these next 4 examples, we're going to convert to exponential equation. And y'all, I'll write my conversion up here. Remember, I had log of a of y equaled x. And then this was a to the x equals y. All right, y'all. So these started at 21. So they're giving me log base 2 of 4 equals 2. So to go to exponential, I need my base first, which is the a. Well, that's the base of the log. So that's going to be 2. I need my exponent, which is x. Well, remember, the log found the exponent, which is 2. And 2 squared has to equal 4. Okay, so that's a trick. Just keep that conversion going. So let me see what this one has. Log 0.01 equals -2. All right, y'all. So let me ask y'all this. There's not a base on this logarithm. So what are we using? Oh, you don't let me get y'all. Remember, if there's not a base by the logarithm, y'all, well, my pen ain't wanting to stay out. There's not a base by that logarithm, it's automatically a 10, okay? So this will be 10 exponent -2 equals 0.01. Okay, so remember, no base, it's got to be a 10. All right, this one is an ln 61 equals 4.1109. Oh, so that's the ln. What is its base? And remember, we said an ln is a log base e. Remember, this is really a log base e of 61 equals 4.1109. So your base is an e, exponent is the 4.1109, and that's going to equal the result of a 61. Oh, y'all, one more of these. They got a log base n of m equals negative x. So they always sort of throw one in with just letters. So the base is the n. Exponent is that negative x, and that's going to equal the result of a capital M. All right, y'all. So the last few of these problems is just using the calculator. So use a calculator to find the common log. Now, the common log is the log on front of that calculator. Remember, the common log is the log base 10 we said earlier. Okay? So these started at 25. And they want us to round them 4 decimal places. So I got log 99. All right, y'all, so you'd use your calculator for that. Go to that calculator. Log is right on the front. And then put in 99, enter. So if I'm going 4 decimal places, that's going to be 1.995. Let's see, the 6 is in the 4th spot. Got a 3 after it, so I'm going to leave that a 6. So 1.9956. So that's what they're doing in that section. But y'all, let me do one like 27. Log of a negative 46. So y'all push that in and tell me what we get. So y'all, it's an error on that. Because remember, this is a log base 10 here, right? So there's no exponent that I can raise 10 to turn it into a negative number. Nothing I can do to a 10 will ever make it negative. So we say that this does not exist. Okay, there's no way to turn any number into a negative number using exponents, okay? Oh, y'all, so you had like 3 of them, I think, and then there's 3 doing this one. Use a calculator to find the natural log. And they even tell you that that's base E. Okay? So let's see. These ones started around 28. So they got LN 55. Now, in MATLAB, if you ever have to write this, that is a LN, not an IN. It is a little L and a little N. Okay? That's why I was writing it earlier with the capital letters so you could understand that that's a LN, LN, okay? LN. So we got the LN on front of the calculator also. So LN of 55. They want me to go 4 decimal places. So that'll be 4.007. Let's see, 3's in the 4th spot. Got a 3 after it, so we'll keep that a 3. So 4.0073. All right, y'all, then the last one I'm going to do like number 30 here. See what y'all do here. Ln of negative 0.19. So y'all got an LN, punch that one in and see what you get. So you got another error. So there's nothing I can do to that E to turn it into a negative number again. So y'all, if you try to take the log of a negative number or the ln of a negative number, those do not exist. Nothing I can do to any number to make it negative using exponents, okay? All right, y'all, so that was 9-4, just getting you really used to using that calculator with the logarithms and then some of these conversions so that when we solve equations Friday, you'll be able to convert back and forth, okay? So tomorrow will probably be a little mellower. We're only going to do 9-5 tomorrow. And then Friday, we're only going to do 9-6, okay? So do y'all have any questions? Did y'all have any questions out of the stuff y'all did yesterday? I had to send you the video for. Were y'all good on that? Or was there any questions? Now look, and most of y'all did pretty good on those, so. Alrighty, y'all, so let me stop my recording.